Hello friends, so today we are going to discuss the hangover problem. So our problem is basically we are given some amounts of card and we have to keep them over a table in such a manner that for the first card should hang half of the portion out of the table. The second card should hang 1/3 portion out of the table. Third card should hang 1/4 and so on. So this is our problem. So we have to write a code for this. So let us explain the sample inputs. So like we'll be given floating point integers, so they will be something like 1.00, 3.70, and we have to say how many cards are required for this much length to be hanging outside the table. So suppose this whole length is 3.71, so how many cards are required for that many for this much length to be hanging out of the table. So let's see what can be our approach to this problem. So what we can do is we can have an array. In that array we can fill all the possible length length and corresponding number of cards. So suppose if we have a length of zero point 0.5, so only one card is required for filling 0.5. For two cards you require 1 plus 1 by 3. For 3 cards you require 1 by 2 plus 1 by 3 plus 1 by 4, and so on. In this manner we'll fill an array, and till how much limit we should fill, so that we can see in the question the maximum length which we need is 5.02. So we'll fill it up to 5.02 till the time our length is 5.02. So now you can see if we how can we write 1 plus 1 by 3. So if we assume this array to be length len and the index is I, index is basically the number of cards which we want, the number of cards required to print this length, so to make this length. So len of I is equal to len of I minus 1 plus 1 by I plus 1. So as you can observe here, assuming that this is len of 2, you see this half is nothing but len of 1. This array is len of I, where I is the running index. So this is nothing but len of 1, and this thing is nothing but I plus 1, where I is 2, so it becomes 1 by 3. So we have a formula for our uh, length of the card. So if we require any length, we can find the number of cards required for it in O of n time. So I want you to come up with an algorithm which does this for us in log n of time. So better pause this video for a moment and then come back again. So I'll wait for you. So like some of you may be able to solve this problem, but then let me explain it to you. So what we'll do is we'll in our given array we'll set a particular middle. So we'll have one left index and a right index, and we'll set a mid that is equal to L plus R by 2. So what we'll do, if our length which we have to find, suppose we have to find x, if our length of mid minus x is less than 0, so that means x is greater than length of mid. So if this condition satisfies, then definitely our x will be in this part of the array. So what we'll do, we'll just shift this L to the mid. We'll shift L to mid, and then we'll call this same algorithm iteratively. Means we again we'll find again we'll set this L to mid, and then again we'll run this loop again. So basically what we'll do is again we'll compare whether uh, length of mid, because once our L is shifted we will find new mid using this value of L, and then again we'll see whether length of mid minus x is 0 or not. If it is less than L, so we'll shift our R to some particular point and then we'll continue. Now since our len and x both are real numbers, so we need to control the accuracy of errors. For doing that, we'll define a zero function such that it is equal to 1 when x is greater than delta, minus 1 when x is less than minus delta, and 0 otherwise, where delta is equal to 10 power minus 8, or as you write in C, 1e minus 8. So this is our zero function, so to control the accuracy. Suppose here if we have to check whether len of mid minus x is less than 0, so we'll do nothing but 0 of len mid minus x is less than 0. So zero function will either return minus 1 or 0. So we'll definitely get to know whether 0 of len of mid is less than 0 or not, and accordingly we'll do our thing. So now let's go and see some code for this program. So as you can see, we have defined our maximum size of array, that is 300, and then we have defined our delta for our zero function. Then we have defined our zero function, that is nothing but the same definition which we saw there. And then we have our main function. So in main function we have defined a array of character double, so we can store all the real numbers, and then we have defined a variable total. So first we have kept our initial base case length of 0 equals to 0, because if there are no cards, then our length which is required is basically 0. And then we start filling our array of len by running iteratively on a for loop, and we use this formula which we had derived using our using our question. Then we declare another variable known as x, that is our length which we have to take as input, and then we take it as input. And then while 0 of x means while x is not 0, like when you get 0.00, you should stop. So while 0 of x, we put it in our zero function, and then we set our left and right pointers, and then we initialize left to 0 and right to the end of our array, that is total. So and we run this while loop. What happens in this while loop is, suppose we take for example we are taking 5, 6, 7, 8, 9, 10 and 11. So suppose right now we initialize our L here and R here. So we then put if now suppose we have to find 9. So let me change the color. So we have to find 9. So for finding 9, we'll first take a mid. So we'll be taking mid equals to L plus R by 2. So 8 will be our mid. So once our mid is decided, we'll check whether len of 0 of len of mid minus x is less than 0 or not. So we'll take len of mid is 8 minus 9, this is equal to minus 1, and 0 of minus 1 is also equals to minus 1. So this is definitely less than 0. If it is less than 0, we'll bring our L to mid. Our L comes here. Once our L comes here, we again run the loop, and then again we find the new mid. So this is 0, 1, 2 and 3. So our new mid will be 3 plus 6 by 2, that is equal to 4.5. But in C programming we always take the lower, if you divide something then we take the lower limit, so we get it 4. So our mid will be 4. So once we have 4, then again we check for the condition that L of n minus L of mid minus x is less than 0 or not. But in this case it's false, because L of mid is also 4, and as well what we x is also 4. So this condition will be false. So else R will be equal to mid, or R will be here. And then if we go in while loops condition, L plus 1 should be less than R. That condition will be also false because L plus 1 is equal to R. So this condition will also false. So we'll be out of the loop. And then we'll be printing our R. So as you can see, our R and what we had to find X both are equal. So we'll be printing our answer, and then we'll be scanning our X for another input. Okay then guys, today thank you. This is all for today. Please be sure to like and subscribe.